This problem specifically tells us we have an indirect titration. So we're going to have two chemical formulas we're going to be working with. So we start with a 25 milliliter aliquot or sample of a solution that contains sulfide ions. And we're going to add that to 25 milliliters of a 0.015 molar copper 2 solution. So then we're going to make a copper sulfide precipitate, and then that will be filtered and washed. Now, the pH of the combined filtrate and washings was then adjusted by the addition of ammonia, and the solution was titrated with 0.0133 molar EDTA using a suitable indicator. So the endpoint volume was found to be 12.11 milliliters, and this is EDTA. So now comes the chemistry knowledge that you need to have. What does this EDTA represent? Well, this is going to represent excess copper. So we have a total copper, we have an excess copper, so we need to know how much copper reacted. So this is another one of those. Total is going to be equal to excess plus the amount reacted. And we're going to look at moles for this. So the total copper is going to be represented then by this calculation. We're going to take 0.015 moles per liter, and we're going to multiply it by the volume in liters, 0.2500 liters, and then we will get the amount of moles of copper that was added to the solution. So I get 3.75 times 10 to the negative 4 moles of copper. So the excess copper then is related to the EDTA. The EDTA treated the extra copper in order to find out how much extra copper there was. So we will use the same type of reaction or the same type of calculation. I'm going to take the volume, 0.01211 liters of EDTA, and I'm going to multiply it by the the concentration, 0.0133 moles of EDTA per 1 liter of EDTA. Now, we can't subtract moles of EDTA from moles of copper. We need to make sure we are using moles of copper. Now, we happen to know that 1 mole of EDTA will react with 1 mole of copper. So, to calculate our moles of copper then, 0.01211 times 0.0133, we get 1.61 times 10 to the negative 4, that is a 4 moles of copper in excess. So now we can calculate how many moles of copper reacted with our sulfur. And this is a straight subtraction problem. So we take 3.75 times 10 to the negative 4th, and we subtract 1.61 times 10 to the negative 4th. So the moles of copper that reacted with the sulfur is then 2.13937, those are all of the digits in my calculator, times 10 to the negative 4th. Again, that is moles of copper. But that doesn't answer the question. The question is specifically find the molarity of the sulfide in the sample solution. So we take our moles of copper and we look at our balanced chemical equation here. We have 1 mole of copper 2 reacts with 1 mole of sulfide ion. So we can get our moles of sulfide ion, which happens to be the same value, 2.139 times 10 to the negative 4. And we divide that by the original sample volume in liters, 0.02500. And I find the molarity of the sulfide ion in the original solution is then 8.56 times 10 to the negative 3rd, capital M, molar. Now, looking back, it looks like we have 2 significant figures here. We have 3 significant figures here, 4 here, 4 here, and 4 here. So realistically, we should probably only report 2 significant digits.